spent around 5 to 6 labs. So with CS3, I am already engaging the discussions on SQL. So I'm expecting similarly CS1 and CS2 is also having their labs on these basic concepts, right? So primarily because till now, what we have done, we have discussed the different concepts to basically how to model the data requirements mentioned in a document and how to achieve this conceptual data model first, and on the second instance how to map a particular conceptual model, data model, conceptual data model into the logical data model, which we are referring as a logical schema primarily, right? So I mean, after having this logical schema in your hand, actually you have to implement it. You have to actually define or create it on the system, which we are referring as a database system, right? So logical schema is what we have derived in the previous, based on the discussion on the previous lectures, we will be able to derive the logical schema. So in logical schema, we will have naturally the database tables now, and then within tables we will have attributes, particularly like primary key attribute and other attributes, and along with this there is a concept called foreign key, which we will have in the logical schema. So when you compare this conceptual schema and logical schema, the one thing is very important, that in the case of logical schema we have implemented this concept called foreign key, but in the case of conceptual schema it's not there. There we have basically there we have defined or modeled the relationship. The concept of relationship is already there, right, which captures this dependency or the relation between two entities. So that's the primary difference. And the case of conceptual schema, we have mentioned the level of cardinality, right? So that's how we have mapped the conceptual schema into logical schema. And now probably the last task of database designing is the creation of, or maybe the implementation of logical schema into the actual database, right? Actual database instance, right? So this process actually, whenever we are actually implementing something into the systems, you need some maybe some instructions or maybe some programming language, right? So in the case of database, whenever we want to implement something, uh, there you need a specific language, which we are referring as a query language, right? So like in typical scenarios, we used to have a programming language like C, C++, Java, Python. There are many languages are there, but when it is related to the creation of database, right, the query language is something which is being created, right? So the objective of any query language is to basically create the database. Then if you need to perform some changes, you need to have some sort of manipulative instructions which will help you to manipulate or change the database structure as well as database values. And in some cases it will help you to perform some high end operations which will help to improve the overall performance of database, something like that, right? So primarily the query language, any query language, I mean, we have few query languages, and one of them is SQL. Actually, SQL is the prominently used query language. So the objective of query language is to help to the database designer in the creation of database, manipulation of database, overall management of the database or maybe objects. So I'm using this term database and object with reference that in the database there will be beyond a database. There are many things which are beyond a simple database thing, right? Like we are referring term database table. We will be referring term database views, something like that. So when I say database object, it means there are something which are addition to the database term, right? So these things we will be discussing now. Whenever we are trying to create or trying to implement the logical schema, there could be other things. There could be different terms you will be facing. Like we will be discussing about uh, the different objects. Just we have just referred, and these objects are like, it could be a database also. It could be a tables. It could be a attribute. It could be in some cases views also, in some cases a trigger and packages. There are many things which are basically encapsulated in the term called database object, right? Now, from here actually, because we are creating the database, we are implementing the database, we will be using the term attribute, tuples, attribute domain. So these are the somewhat familiar terms to you, but specifically whenever we have a created version of logical schema, we should be carefully using these terms, right? So prior to this, we can use anything, like it could be the row, it could be the anything, but precisely when we have a created version of logical schema, it should be using these terms to identify it, right? Along with it, naturally, we will be implementing or we will be defining constraints on the database table, because that's what the purpose also. We are trying to create a relational database. And whenever we say it is a relational database, it means it will be implementing these constraints, because these constraints are something which will help you to achieve the property of uniqueness on the database. And this property of uniqueness is the philosophy of relational database, right? So this is something which we are going to introduce. Now there is this concept called null value. So we will be talking about this null value while we will be discussing in the upcoming lectures about DML, which is one of the set of SQL. So because null values are something very important, a significant concept, and along with it, we will, whenever we will be talking about null values, we will naturally discuss about the possible three-valued logic, right? So whenever we have null values in two attributes and we want to compare it, so whenever you compare null value with null value of two different attributes, you need to see, you need to verify how the possible answers will be happening naturally, right? So in typical conventions, whenever we see a null value in any particular column or any particular attribute, there could be three possible scenarios because of which null value has been placed in a certain attribute or within particular record place, right? The first obvious reason is the values are not available, right? Second possible could be the value is not applicable for that particular row, something like that, right? And in some cases, it is like the value does not exist at all, right? So there could be three reasons. That's why we need three valued logic. So for any place, for any database attribute, if you observe that there is a null value, the reason could be these three reasons, right? And that's why it is difficult to validate that what could be the reason of having this value is a null in the particular attribute, right? So naturally from here we will be, I mean, because we are talking about how to create a database table uh, and based on the logical schema naturally. So whenever we are looking upon this, the very first obvious step is to create the database tables with appropriate constraints and data type. The next step is naturally, once you have a database structure with us, database table structure with us, the next possible step is to upload or some record some value into it, which we are referring as a population. So for each database table, you can always upload some values into it. So these are the two primary steps which we need to perform, and after that we can say that the database is ready for use, right? But as a database designer, because this is something which we have taken as a philosophy for this course at least, that whatever we will discuss in this whole or entire class from lecture 1 to lecture 30th, the philosophy is to understand what is the different task a database designer has to perform, right? As a database user, you can always think about that what is the data values are there, how to retrieve the data part, but the main purpose of this course is to have understanding with the perspective of database designer, right? So as a database designer, you have to perform two tasks. First one is to create the database structure itself, database definition itself. Then second is actually to, based on the inputs, based on the given data set to you, you need to upload them into the database tables within a database. So typically in the left side figure, you can see this particular instance is the logical schema instance, which we have discussed previously. So here you can see different different database tables, not entity, different database tables, their respective attributes, and within the attribute set, you could spot that different attributes as a foreign key, right? And naturally, in the process of database implementation or implementation, you can create structure and upload the data. So right side figure or right side diagram will explain that this will be the structure that data will be or database will be available for use at the end of the second step. Right now, this is something which we have given. I mean, this instance which is visible in the right side, it is something which we have given for the experimentation in the labs, at least for the CS3 section right now. Right. So this is what they are trying to create. Now, going ahead, naturally, because to perform this task of implementation of database, you need a specific query language, and query language are specifically designed for implementing the database. In this, what we have done, we have focused upon the specific query language which is called structured query language, and which is abbreviated as SQL. So the purpose of SQL is to implement the relational database. Naturally, I mean, I can say that you can implement any database, but specifically whenever it is said the SQL has been used to implement the database, it is naturally to design, or it is naturally to implement the relational database. That is the main philosophy why SQL has been created, right? So whenever we say it is to implement the relational database, and it's schema naturally, right? Now, uh, most of the data based software, DBMS softwares, are having this SQL inbuilt into them, so that the DBA or maybe any programmer can create these databases and their specific relational database. So SQL, whatever version we are reading, whatever with scope we are reading, it is considered, or it is assumed as a basic version. It is having limited set of inspection, limited set of clauses through which you can create the database, you can upload the records, and you can retrieve some data, right? So, and the basic version of SQL does not provide any automation kind of things, right? Like in the case of C language or C++, you can always write a loops, or maybe some logics by which you can automate something, automate operation. But in the case of SQL, there will be no specific clause existing which by which you can automate some operation, automate some data updation, or maybe update some values, right? And there is this version of SQL which is referred as PL SQL, right? It is considered as the advanced version of SQL, which will have some clauses, some concepts through which you can always automate some operations on the data values, database tables, right? So typically, if you compare, the basic version of SQL uh, provides you the operation on these three concepts, three database objects. First one is naturally database. You can create database, you can update database, something like that. Then the second object type, which is handled in the SQL, is tables. You can create database table, you can update database table, you can perform any operation on the database. There is a third object which is referred as views. So you can always create views for improving the query retrieval. So we will discuss all these three types. Now, in the PL SQL, if you see, there are few other terms are mentioned which are there to automate the operation. So these different objects, which is like a trigger, procedure, package, there are more than that also, but these are primarily designed to provide some automation, some sort of automation on the database, right, for user request or maybe my specific need. So that's the two set of expressions we have. First is basic SQL, second is the extended level, which is called PL SQL. So here PL stands for procedural language. So when we say procedural, it means by default it provides some kind of automated procedure execution, something like that. But when we say SQL, it is a non-procedural language, because it does not have anything into it which can automate. That's one thing. Second thing, it is written with a specific set of expression into it, right? So you can always read about the brief history about SQL, why it is called SQL, what is the previous name of SQL, like it was previously called SQL, something like that, and why it is referred as structured query language. So what is the mean of structured, the first term? We have discussed these things along with the CS3 in some sections. So I'm specifically mentioning these things because it is not being, I don't know in which shape it is, it has been discussed with students of CS1 and CS2 section, right? So you need to always find out the basic answers of this question. Why SQL is called SQL? What was the previous name? Why structured term is abbreviated with the QL? So because QL stands for query language, which is clear to us. Now, why this structure term is mentioned here? What does it mean, right? And why we are saying that SQL is a non-procedural, and there is this advanced version which we are referring as a PL SQL, right? That's what. The second aspect which is important here, that in the different DBMS we are having different modified version of SQL. I'm saying, like if you take one of the DBMS, they are having one type of SQL, and the second DBMS you could have different type of SQL. So because of this, in some cases, few operations are similar, few operations or few instructions are well supported in all the DBMS, but in some cases you will find that a particular expression is not working in MySQL, it is working in Oracle, something like that. So more or less, most of the portions which are falling under SQL, because each and every DMS will have SQL as well as PL SQL, right? So most of the portions which are coming under SQL are similar or common in each and every DBMS. But the portions or the commands or the set of expressions which are falling under the trigger, package, and procedure part, those are the something which will be different in the different DBMS software, right? So from here, let's see what are the different expressions that we will have in the case of SQL, right? So primarily the SQL, the basic SQL is having three broad set of expressions, right? And naturally all three will be used by different set of users. So I'm not saying exactly here what kind of user he will be using, right? So like the very first set is called as a DDL, which is called data definition language, and this is purely, so this set DDL is purely being used by programmer and DBA user. That's what we have mentioned, that a programmer, the database programmer, and a DBA user will be using this expression. There is a no instance where a simple user, a naive user, could be executing these expressions, right? Because through DDL, we will be able to create the database object structure. Primarily, it is called definition also, right? So by using DDL, we will be able to create the definition or a structure or syntax. So that's why these set of expression will not be provided to a simple user of the database, right? The purpose of DDL objects obviously is to, it will provide you the set of clauses through which you can create the database objects. I'm saying objects, right? I'm not saying database, I'm saying database object. It means it could be database, it could be table, it could be view, it could be procedure, package, trigger, anything. You can create anything. So it's basically the purpose of DDL is to create, to update, to provide modification capability, to renaming or to removing itself, right? So there are few basic operations which also we need as a database programmer while we are dealing with the database. So these all possible operations on database structure, database definition, you will be handled by different clauses on the DDL set. So what are the different clauses you can see? You can see create, alter, truncate, drop, rename. So these are the various 5 basic set of clauses which is available, which is existing in the DDL set. Naturally, as you can read, that create is there to create the database structure. Database structure means you can create the database table, you can create the database itself, right? Similarly, alter says there is, if there is need of modification of database object, you can modify that. Truncate is for truncating, drop is for dropping or removing object, rename is for renaming the object. So you can see whatever clause we are discussing right now, uh, these these clauses are basically coming from the proper English dictionary. That's one thing. And each and every clause is a specific kind of English word which is called structured English word. So structured English words are the English words which represents a process, which represents a procedure. So create say it is a verb, it is for creating something. Alter says it is a verb and it is for altering something. So each and every clause which we will be discussing in SQL will be a kind of structured English word, and that's what the meaning of this structured term in the SQL. The full form of SQL is structured query language, and it is said structured query language. So this structured term is referring to these things only, that each and every clause in the SQL is a structured English set, right? And that's why the first name of SQL was SQL, SEQEL, which is Structured English Query Language. But in the recent years, it has been renamed as SQL, which is Structured Query Language. Right? There is no other reason for this thing. Now, going further, so by DDL, we will be able to create the data definition, right? Right. So we will be discussing about each and every clause in the upcoming discussions. After that, once we have created the database definition, database syntax, the obvious next task is to provide some sort of clause, some sort of features through which you can upload the values, through which you can update the values onto this created definition. So for that, we have second set, which is called DML, data manipulation language. And by this, you can what we can do, we can insert the data values, update the data values, and delete the data values. So these are the three possible operations we need on the database values, right? So when we upload the values onto the database, we can use insert. When values are inserted and you need to perform some updation, you can update the values by using update clause. And in some cases, if you need to remove them, you can always use delete, right? And that's why we have three broad clauses. Now again, you can see these three different clauses are proper English words, and they are indicating towards a process. Right now, what are the different users you can see about this particular set? So for DML set, it is the programmer user who can use these three clauses. And in some cases, whenever user initiate a transaction, these DML expressions will be used. Like for a banking operation where you are transferring some amount from your account to other account, your transaction will initiate some DML kind of queries in the background, right? So after having these values updated in the database, you can always claim that my database is ready for use, right? You can always claim that the database can be now used by the data different users. But there is a specific set of queries, a specific set of operations or action on the database which only read the data. They are not going to manipulate the data. So these set of expressions or this set of queries are referred as a retrieval query, right? Retrieval query, which basically simply retrieve the data or extract the data. They will not have any manipulation kind of situation into it, right? So to perform this retrieval kind of query, we will have a specific set of clause which are referred as a maybe select clause, from clause, where clause, group by, having, order by. So there are the 6 clauses which will be used for in the you while we are retrieving the data. These 6 clauses will be required. Not all, maybe only 2 will be sufficient. Others may be required based on the scenario, based on the query statement from the user, right? So primarily it is said that the retrieval queries are primarily needed because there might be some request from the naive user who is requesting for some data to be retrieved. That's why these queries are required there. Now after this, there is a last set of expression which is called as a DCL, right? And it is primarily to provide or control the access over a specific database object. So suppose you have created a database table and you want to control the access on the database table to a specific user. All right. So suppose in the database there might be 100 users or maybe 3-4 types of user. So if you want to control the access to certain set of user on a specific set of attribute, that you can provide. So the entire purpose of DCL to control the access, define the access on a user label, right? So these are the set of expressions which can be used by a programmer itself, right? So programmer and DBA, you can write here, DBA are the user for this set of expression, right? Now after having this brief discussion or brief summary about this thing, naturally in the upcoming classes we will be going through each and every clause and each and every function which is required in the SQL discussion. We will discuss each and every about how to use it, what is the syntax for that. So let's begin discussing, because we have started discussing. So now you can summarize it. Like in the DDL, we have create, alter, drop, in truncate or rename. In DML, we have insert, update, and delete. For DCL, it is grant and revoke. And in the case of retrieval query, we could have select, from, where, order by, having, group by. These are the clauses, and there could be many functions in the retrieval query which could be used, right? So out of these four categories of expression, retrieval queries are something which are contributing most of the presence. So it is like in the database lifetime, retrieval queries are appearing in the database with the percentage of 95%, because DDL is kind of, it is a it is kind of one-time job. So once you're done with the DDL part, there are very really chances that you are again going to perform some DDL tasks. Similarly, the DML is naturally having some presence. It is again having presence of 3%, something like that, because most of the queries are either of nature retrieval or maybe either of DML part, right? So again, granted in the revoke is about again 1%, so something like that, right? This is the percentage of types of query coming on the database, right? So let's begin. I mean, the very first set of expression is naturally is referred as a DDL, and the objective of DDL is to create the database object. So I am simply specifying database object term. It means those 5-6 things which you can create by using those by using 5 different clauses, right? Now, so what is the first task you have to perform? So while creating a database or while implementing a logical schema, the very first obvious task is to create the database, creating a specific space within the system where you can introduce your tables, objects, their attributes, each and everything, right? So that's why it is kind of compulsion, a kind of mandatory situation to create the database object in the very first step, right? So once you create a database object, the next obvious task is to use it, use the specific database, and after that you can naturally within that database space you can always create the database table as you need, right? I'm saying as you need means if you see this is statement, it is able to create a database table within the database college, right? So here we have mentioned db1, but it is a college, right? So by using a simple expression you can always write database table. So expression will be like create table student. So because SQL is not a case sensitive, so you can write create table student first name, which is the first attribute, then its data type with data size, then again second attribute with the separator. Now separator you need to mention roll number, its data type again, and its size, then DOB with its data type date. So by this statement you can create a simple database table student. I'm saying simple, it is not a relational because we have not imposed any constraint onto this specific table, right? So after creating any database table, you can always look for the possible structure being created. So you can use describe student specific expression which will give you the idea that what is the structure we have created by using create statement, right? So after that, I mean, after creating each and every instance on the database itself, you need to, or I think this is the kind of ideal practice also. So whenever you create a database table, you should look for the structure. You should verify the structure by using describe student or describe that particular table name, right? So with this, let's see how to introduce the constraint, because just now we have created a basic table. Now let's try to create a basic table along with the constraint, which can be referred as a relational database table. So to create a specific relational database table, you need to mention the constraint along with the attributes. That's the additional thing which will be appearing. So like now you can see we have mentioned expression which is like attribute name, then its data type, data size, and then this constraint name. So along with each attribute you can always mention the constraint, and actually after that you can go for the next attribute. So by this you can always mention the constraint, specify the constraint and the possible value. Like for the d name, you can see for d name the data type is character, size is 10, and because we are trying to introduce the constraint in the d name with check value, check constraints, so along with check, which is the name of constraint, you need to list values and the list of values, because that's what we are going to perform in the future. That's what the purpose of check constraint also. It will what? It will define the set of values which will be introduced in the future into this particular database attribute, database table attribute. Similarly, for the CNAME, which could be defined as a default values. So here also you need to define set default as this specific value. So you need to mention the values. You need to mention the possible set of values which could be allowed in particular attribute domain. So by this simple expression, you can impose or you can define these constraints onto the table and say the relational database table is created with these constraints. Similarly, there is a typical case we have discussed also that in some cases a database table could have more than more than one attributes as a part of primary key. So to create that, you could write the other version of create statement, which takes like create a table, any table like department, which could have more than one attribute as a primary key. So create table department. We have defined the attribute dname character 5. We have defined dnumber integer 5. We have defined department location character 10. Now, because we are trying to introduce the primary key on pair of attributes, so we could use like after introducing these three attributes, you can add this statement like primary key on dname comma dnumber. So by specifying primary key constraint in this manner, you can easily define the primary key on the pair of attributes. So similarly, you can add third attribute also. So whenever you feel that for a specific table more than one attributes are acting as a primary key, then you should look for this syntax. And if you feel that there is only one attribute which will be acting as a primary key, then you can simply follow this syntax where roll number, integer 10, and primary key. So you can always mention the constraint along with the attributes definition. But when you feel the second situation where more than two attributes are part of primary key, you can always go for this convention, right? So this is about creating the basic database table, creating a relational database table with the basic set of constraint, creating a database table with two attributes as a part of primary key. Now, let's take the another concept which is important and significant, and it is the concept of foreign key. So foreign key concept is something which we have discussed in the previous lecture, that because of the relationship concept in the conceptual schema, the foreign key is required when we map the conceptual schema into the logical schema, and it is because of the relationship between pair of entities. So till now what we have discussed that how to impose constraint on a specific table. Now in the database, when we realize that more than two entities are involved in a relationship, we need to model this relationship in a form which is called by using concept called foreign key, right? So that's why we say whenever we have involved more than one database tables, it is the concept which will help you to model that relationship. It defines the relationship among these between these pair of tables, right? And in some cases it is referred as a parent and child relationship. That's what we have said also, like between the department and student, department is a parent table and child is a the student is a child table because of the relationship which we have defined, the relationship cardinality which has been used, right? And in future when we define this foreign key constraint on a database table, naturally on the child table, so we will be imposing the foreign key constraint, foreign key logic onto the child table, and in the child table it will control the repeating or redundant value instances. That's the objective, right? So the effect of foreign key will be the control values in the child table attribute. So typically we are not going to read these things because we have taken the examples, we have discussed the conceptual data model in detail. Now let's see how to create the foreign key thing, foreign key concept. Now again we have taken the same example. So we have defined two tables, two entities. First one is the student and then is the department. So when we realize that there is a relationship between department and student, and the relationship cardinality is 1:m, where in one department more than one students are enrolled. So how to define this, how to create this scenario, right? So you can easily create the department table with the basic configuration, because the department table is a parent table. So you should not concern about the foreign key on the case of department. But whenever while you are creating the child table, so for us it is the student table, which is a child table. So while creating the child table, you need to take care about the foreign key clause, foreign key concern, right? So you will be simply defining create table student, the name, character, not null, then roll number will be a primary key for that, date of birth is there. Now D name is there, which will be acting as a foreign key. So in the local table, on the child table student, this D name is defined as D name. Uh, After that, after initializing this, after defining this, you can add this constraint like foreign key, D name, references, department name, right? So this could be possible that by using this simple expression, the foreign key will be implemented, foreign key constraint will be defined, right? So this is something specific line. So here you can see this foreign key on D name. So this D name is basically is the attribute which is defined in the student table, right? And it is referring to this D name attribute, which is the foreign key in the student table, is to referring to the department table and its D name attribute, right? So this D name is of the department table, right? That is obviously implied also. And in the future, all the values in the D name of the student will be inherited, will be coming, will be mapped from the department's D name. You cannot insert any value which is not existing in the department's D name, and you cannot insert them here. So you should always look for the department's D name whenever you are introducing a value into student's D name. That is the effect of foreign key. That is the effect of implication of foreign key concept in the relational database, right? So with this, you can see now there is a one specific concern that while creating a child table, you need to make sure that the parent table is already created, right? If you're creating a child table with foreign key without concerning or without creating the parent table, it will throw an error. It will generate error, which is like maybe the foreign object is not found, something like that, right? And that's one thing. Second thing, whenever we are using a attribute, like here we have used D name in the parent table, it should be a it should be or it must be a primary key only, right? This is kind of clause also. So while defining a foreign key, you need to concern about these two things. Now there is the additional thing which we are going to discuss today, and after that we will complete this discussion. So there is this a specific clause or a specific concept which is called uh, on delete or on update effect or clause. So this is something is required for dealing with the different cases while defined. So because we have defined the parent child relationship by using foreign key, and we have said that the domain of the foreign key attribute in the child table is entirely dependent on the domain of parent table and its primary key attribute. Now there are some, so when we say this domain of both attributes are dependent, it means we cannot perform any changes on the parent table without informing the child table. But there are some situations where you need to allow them, where you need to have this exemption, right? So for that purpose, this concept of on delete, on update is required. So let's take this scenario and discuss, right? So these two concepts, on delete and on update, provide some sort of automated validation of the values. So this implements update and deletion operation on the parent table attribute to its all the child table attribute, right, domain. So like department number is a parent table and its D number is the attribute, primary attribute. And suppose this D number has been used in more than one database table as a foreign key, then you need to take care about each and every database table. So it is sometimes difficult also. So that's why these clauses have been introduced in the recent years in the part of SQL. Now, what is the purpose of it? How basically it will be affecting? So you need to say, or you need to see this case, this typical expression again. Let's see this typical expression. What we have done, we have defined create table student. with the attributes, roll number as a primary key, the department number is a foreign key. Now, what we have done, we have defined foreign key and the department number, referencing to department's D number, right? That's what we have just defined. Now, we have added two clauses here. Along with this foreign key definition, what we have done, we have simplified, uh, simply added on delete as a new thing in onto it, and on update, right? It means, so when we mention this on delete, on update, so these two clauses will check, will see the changes on the parents table attribute, means department number. So whenever there is a change, there is a manipulation in the domain of department number, particularly due to deletion, due to updation. We are not concerning about insert. So whenever there is a change in the parents table attribute related to delete or to related to update, domain of a parent table attribute related to delete and update, these will affect the domain of child's attribute. And by how? That's what we have defined. So whenever there is a change on delete, so suppose there is a deletion in the parents attribute, parent table and its attribute, we will set null for all the respective values in the child table. So suppose in the parent table there is a value called department number 1, and we are deleting this department number 1 value in the parent table. In all the child tables, wherever this department number 1 is used, it will be now set. It will be now set as a null because we have deleted the value from the parent table. Similarly, if there is a change in the value, if there is update on the parent table and its attribute happened, the same change will be happening in the same update will be happening in all the child tables attribute. This is the typical simplification or simplified discussion. So whenever we mention on delete and on update, it will all the time it will see the possible action on the parent table, and its effect will be, its effect on the child table will be reflected based on the parameter which we define. So like along with the on delete, like with the on delete, you can use on delete cascade. On delete cascade simply say, if we are deleting something from the parent table, in the child table it will be deleted likewise, right? If we say on delete set null, it says if we delete something from the parent table in its attribute, in the child table the value, respective values in the child tables will be set as null. If we say on delete set default 000, it means on the deletion on the parent table, right, in the child's table the value will be set as 000, something like that. Similarly, if you mention on update, and if you see how it can be paired, so on update, if you mention on update cascade, which is the most often used, so it says whenever we are updating a value on the parent table, the same change on the value on the child tables and their foreign key attributes will be reflected. Same change, like if you update the department number 2 with 6, so in each child table on their respective values, the department number will be updated, right? So second pair could be on update set null. So whenever there is updation in the values in the parent table, the respective child value will be set as null. Similarly with the set default. So this is the typical reflection will be happening in the child table, right? So this is something you can say the maximum possible, or you can say this is with the addition of on delete and update, we can claim that our create statement is completely covered. So this is the something which we can say is as a full-fledged, full verified, validated, completed statement of create, right? So there is nothing beyond this you can add in the create statement, right? So whenever you create a child table, you need to mention this on delete and on update cascade, right? Because with this you can take care about the possible changes on the parent table. Otherwise you have to do it manually. That's what, right? So with this I can say, with this we can say that this create statement on the DDL is completed today. We will talk about the remaining clauses uh, on the create statement in the upcoming classes along with the DML part, right? So if you have anything to ask right now, you can just let me know. We can take few questions